going to start the technical sessions by talking some things about data-driven companies, MapReduce and Spark. My name's Ferran. I work currently at Trovit. I'm sorry about the color, but well, I had some problems. I'm currently working as a lead software engineer at Trovit. I studied at UPC in Barcelona, and I'm also organizer of Spark Meetup Barcelona, where we gather once monthly and speak about this technology. Do you know what's a classified data? If you go to the newspapers, there's always a section where people can put their announcement to ask like for a job or offering job. Since the internet was born, lots of internet sites were open for the same purpose, for making people put their announcements and show themselves to the public. The thing is that when you're searching for something, like for instance, for a home, second-hand car, or a job, what you may find is that there's plenty of websites and plenty of things to look on. So the search can be a bit difficult. So that's why Trovit was created. Trovit is a search engine where if, for instance, you're searching for property for sale in London, you can go to the website and it will show you a set of results that will be an aggregation from different sites. So we make the search of, in this case, important life-changing decisions, changing the home, job, or car. Yeah, we are a search engine, but not like Google that search all over the internet. We're specialized in something called verticals. In this case, is the one that I told you. We are also in several markets. It's supposed to be a map, 42 countries. So you can imagine that running this business is quite challenging. In our case, the engineers, we have lots of data. We have about, well, hundreds of millions of ads stored into our systems to create the search engine. If we want to create products like bookmarks or notifying users, we have to store this data too. And since we have millions of active users per day, 3 million actually, and it's not really obvious to know if the user liked or not our product, we also store the user behavior for further study and analyze if the product is working well or not. 4 years ago, we adopted a technology called Hadoop, which for solving these actually problems of massive amount of data, which it basically consists on having horizontal scalability instead of vertical scalability. So if you have a complex problem or a problem with lots of data, instead of buying a bigger machine, what you'll do is buy more small machines. So your business can grow just by making an investment. Hadoop, it consists on two parts. One is it solves the storage problems with huge amounts of data. It creates a layer called HDFS, Hadoop Distributed File System, which is actually a file system that you put your files in there, and they are actually stored in different machines across the cluster of machines that are distributed. On top of that, there's a computation framework that is called MapReduce, which allows developers to code applications in a unit of computation called job, which this job will read something from the file system, the distributed file system. It will process something, and it will write it back down to disk. Using Hadoop, we solved challenges that we were having at Trovit. That was like just having a good search engine with quality, freshness, and without the duplicates, etc. We provided a set of tools for the business to analyze if our product is working well or not, sets of business intelligence tools. We also, it allowed us to create interesting products for users, like notifying a user when new content or new ad arrives into our systems, like in mailing or just sending push notifications. And also, it allowed us to optimize online media buying. The traffic that we have, a part of it is we invest on buying on several advertisement sites. So with Hadoop, it allowed us to reduce cost and increase the investment that we're doing on that. Not only that, but it allowed us to create quite interesting data for the user, actually value-added data to the end user that is using our product. Like, for instance, you cannot see it properly, but here is statistics about the average rent price in Barcelona, or this one, it's a heat map that shows the average price for sale in this case, Barcelona. Technically, MapReduce, the framework that uses by default Hadoop, it has an API that's not really flexible. So the engineers that have to take a problem and implement it on Hadoop and MapReduce are tied to the API that the MapReduce puts to the user. And it's just, your job it consists on map and reduce. So first you do some map, and then you do some reduce. If you want to do something complex, like reading one file and doing something on it, reading another file, doing something on it, and then join it, you have to actually code 3 MapReduces, which transforms the way that logically you will solve a problem. And also, MapReduce, it's quite disk intensive, so every time a map is executed and every time a reduce is executed, it goes to disk. You know that in hardware, the disk is one of the biggest bottlenecks, so this framework, it can be a bit slow. That's why other frameworks, distributed processing frameworks appeared, like Spark, which solved the same problems, but allowed the developers to code or to solve the problems with a different approach, a bit more flexible. In this case, the API that provides Spark, it's something called RDDs, resilient distributed data sets, which allows you to, for instance, take a data set and you filter it. So you actually code a filter on it. Then you have another one and you are going to do an aggregation of them. So it actually provides this API. Then you join these two data. Eventually you filter them. So all this, it's made, and it provides not just the ones that I explained to you, it provides several sets of routines that you can combine them and represent your problem in a more logical way that just being tied to map or reduce. These transformations eventually are executed by taking some actions, like, for instance, count how many they are here, or writing down to disk, and the processing framework underneath will execute this in a distributed way. The API, it's in Scala, Java, or Python. So it's quite interesting because different kinds of users, from the more hardcore engineers to data scientists, are able to use it quite properly. So if before we were tied to something like that, with Spark we can reduce this to, for instance, map, reduce. So we are avoiding complexity to the problem, and Spark behind intelligently can know if a problem or a relation between two executions can fit in memory or not. So if it fits, by default, it will be faster. If it doesn't fit, it will go to disk, and it will be similar to MapReduce, but this is more intelligently. Also, Spark, it provides, on top of the RDDs API, a set of libraries really useful for the end user. It provides a SQL processing framework where you code SQL, and underneath it's executed on Spark. It provides an interesting set of machine learning libraries, streaming capacities, and graph processing algorithms. In Trovit, we have adopted several months ago, and what Spark allows us is to go a bit to the next level on big data processing. It allows us to improve the way we're doing data science by rapid prototyping and iterating faster through the problems that we have. It allows us to have, by using the libraries that by default provides Spark, apply more intelligence to our systems, and obviously use better our resources that are expensive. It was pretty easy for us to adopt Spark because it integrates really well with Hadoop. So all the code that already is already done with MapReduce, we can keep it, and it's getting executed to the cluster. And Spark appears. It gets executed on the same machines with the same resources, and can work together on top of Hadoop distributed file system on HDFS. I'm going to show you a bit how is Spark. Here I downloaded the tarball from the website, and I'm going to start something called Spark Shell. It's really interesting. Spark. It's really interesting because as Spark provides a Scala and Python API, Scala and Python have REPLs. So you have a command line interface where you can actually write down, and it will compute on interactively. What it's actually done is waking up a Spark cluster on my machine with just one node. It's a distributed system, but in this case, it just have one machine. And I'm not going to show you the example on the Spark shell. I'm going to show you in something called Zeppelin. Do you know what's a notebook for Python? Yeah. So that's actually a notebook for Spark. I'm going to wake it up, and I'm going to go there. Yeah. So here, there's my notebook. You can see it, more or less. Wait. Well, I'm going to wait. I'm going to clear the output. So here I'm going to execute something called sc.version. That will do is start the Spark cluster. It will take a bit because it's getting created, the Spark cluster here. Here we have our Spark. And it says, yeah, sc.version, so Spark, we have the version 1.6.0. Then what I'll do here is creating a variable called Quixote, which is actually reading a text file. So when I'm executing this, what it's creating, it's an RDD, a resilient distributed data set. If I'm going to look on this RDD, Quixote.take 30, what it will do is make an action on top of this RDD. So if we are going here to our Spark cluster. Something it got executed, and it's our take from the text file. As you can see, there's an array of lines. Okay. Then, on top of this RDD, we're going to execute this. This actually what it's doing is splitting every single line on spaces, and it's counting for each word 1, and it's eventually aggregating. So actually what it's doing is for each word counting how many appearances of it. If we execute that, it's creating an RDD. It's not executing anything on behind. But if we try to show count.take30, right now it's executing something, and it shows you the results. So alforjas, derecho, vecindad, etc. If we go here, something got executed, a take, and as you can see, there's a text file, then a flat map, a map, and reduced by key. That's exactly what we coded here. Then I'm going to show you a bit more extensive, an API that appeared in the latest versions that's called data frames, pretty useful for data scientists, where we can take an RDD and transform it into a table. If we execute that, it created something called data frame, where we will be able to execute SQL language on that. In this case, we are selecting for each word the count, the length. We just want the words that has more than 4 letters, and we're ordering it in descending way. Yeah. So we're running it, and it shows us the results. A great thing of using notebooks is that allows us to represent our problems in this case on a web app. It's saved, and it can be executed and re-executed as many times as possible. So it's pretty interesting for iterating through analysis and redoing researches or recovering researches that you have been done like weeks before. So yeah, I got my hands on. I just took some snapshots here, just in case the demo failed, and I'm done with that. Do you have any questions?
Thank you very much, Ferran.